get that. What do you mean by polynomial? It's the answers. So what you're trying to say, 5x minus 7? Yes, that is one of the kind. So what do you think? What is the degree of that? Degree of your polynomial that you have put. We used to use P and X or something like that. Can you give the general formula for the polynomials? Yes, okay. Bhavanjali Ranatunga. Why you didn't put your registration number? So if you don't put your registration number, you won't get the attendance. So you have to change your Zoom account according to the registration number, okay? Otherwise, they won't give you attendance. Okay, good. Let me ask one of the person. $149. Can you give one example? Registration number 149. Can you answer me? Yes, good, good. You all have given a nice answer. Where is 149? Can you give one answer? Zero zero 003. Did you type that? Or just copy it from anywhere? That's 149. It's not here. Okay, I think she or he is absent. Is that? Okay, let's yeah. So chapter 2, section 1. So you can start writing also, okay? Before this heading, let's start with polynomial. So I better go to the okay. So polynomial in the sense, okay, it says it's in the form of polynomials of degree n is a function of the form. Okay, what is the function of the form? They used to notice in this way, or px or anything, okay? So if it is n degree, we used to denote like we start from a naught, or you can start an also, a naught plus a1 x 1 power. If it is the coefficient 1, power also 1, a2 x squared up to last point, let's say an minus 1 x of, what is that? N minus 1 plus an xn. So if you're having like this kind of equation, we called as a polynomial of degree n. Okay, where this a is a real numbers. Okay, real. It's a real. Okay, we call this one as a coefficients. For example, you can say our maybe one of the person give like this. This also one of the polynomials fx. Or let's say fx equal to, if it is quadratic, we'll have x square minus 4x plus 2. Okay. Oh, and the one, let's say fx equal to 4x cube minus 4x plus 1. So some terms may be 0. X to the power squared will be 0. So this is a cubic equation. We call this one as a quadratic equation. Okay. So these kind of things we called as a polynomials. Okay. Can you give me an example which does not a polynomial? Is there like this? Can you write one functions which does not a polynomial? Where is the number 149? Is that absent? I will take that as absent. Okay. I'm still marking. Okay. Here's the answers. Is there any kind of function which is not a polynomial kind? Okay. So we know our polynomial functions in the form of like a naught, a1x. Okay, let me see one of the answer. Yeah, good. Yes, good. Good. Yeah, fine. Okay. So we know this in the form of this way, no? So we have to know these powers are positive. Similarly, if you are having some, for example, fx, let's say 4x cube minus root x or minus 1, something like that. See, this is x to the power half, no? So we should have all the integer parts. So it is also not a polynomial. Or maybe like some people has answered squared minus 1 over x. Like this also, not possible, no? This will be x to the power minus 1. Okay, good. So this kind of can be taken as a not a polynomial kind. Okay. Okay, we have understood what it is, the polynomial is. So what is that doing here in our numerical study? Okay, what is the idea of studying here? So actually the polynomials, as a note, you can write down. Okay, polynomials in numerical methods. So that's what we are studying, numerical analysis or method. Okay, numerical analysis for dealing with functions require, give me a second, functions dealing with dealing with functions require describing them approximately. So actually we in the numerical analysis, what we are doing is we are finding the roots, solution of the equation which has the approximate answer, isn't it? So approximately the polynomial has polynomial can be used to approximate these things. Okay, these functions for dealing with functions require describe them approximately using the polynomials. So in numerical analysis, for dealing with functions which require okay, not the which require describing them approximately using the polynomials. Okay, you can find the answer for this numerical analysis functions approximately by using these polynomials. Okay, so we can study that one. Such polynomial can be used for other for the derivative and integral approximations. Okay. So in numerical analysis, for dealing with functions require describing them approximately using the polynomials. It can be used polynomials. Okay. So anyway, this is just a note. Okay. So why we are studying the polynomial? Because numerical analysis require the approximation for the functions. Okay, approximation for the functions. So this polynomial is very much related to the approximational. So it can be used for that purposes. Okay. What is that? Okay. Okay, that's fine. Now, so let's begin. What are the polynomials we can study here? Okay, let's see some of the different polynomials which can be used to get some approximational functional values. Okay, so the first one, as I'm going in the order of this level, so it's okay. Yeah. Okay. So let's start with the collocation polynomial. Okay. So what do you think? The collocations? Collocation means collocation. Another way, maybe you can use the coincide. Okay. It means it is approximately coincide with the functions. Okay. So that kind of polynomials. So it says a polynomial. Please write down these notes if you want. Okay, a polynomial px, we use p for the polynomial functions. Px is used to substitute for our function. Let's say for you can use fx or yx. Okay, we're gonna use yx for our actual functions. Our approximated polynomial function is px. Px used as a substitute for the function y of x. The difference, let's say yx minus px is what? So we are just approximating now. Did you get that? So here px is a polynomial. Okay, under the collocation polynomial. Let's say collocation polynomial. And yx is our function. Okay. Then the difference between it is somewhere substituting there, but something approximated. So there may be a minor difference now. So that's what we called as the error of the approximations. So that yx minus px we called as a error. Okay, error of the approximation. Okay, then the next point, the collocation polynomial is a polynomial that coincides or collocate with yx at certain specific points. Okay, let's say we have points x0, x1, x2, like that. Let's say xn points. Okay, so they say the collocate polynomial, for example, let's say one kind of a polynomial. Okay, which can be coincide with yx at certain point. For example, let's say here it is okay. It is coincide with the yx and px are equal. Here x3, okay, not x0 or x2, okay, some point, certain specific point, it is coincide with our actual functions yx, okay. So this kind of polynomial we called as a collocation polynomial. Okay, let me continue. Okay, the error has been defined as yx minus px, yx minus px. In some point only it will be they are coinciding, and so we may have some errors, no. So let's say it only x1, x3, x7, x19 on these are the point it is coinciding. So in the point of x1, x2, all the other rest of the points, it is having some difference, no. So when you are adding all those differences, it will be end up like a error. Okay. So that error of collocation polynomial has been given in this formula. Okay. This has a proof. Okay. This section you can study in the Sound series book of numerical analysis. Maybe second, I think second. Okay. So in this book, it has explained very nicely. Okay. The proof also there. Okay. So I'm not gonna use the proof. It is something, but you just know that the error can be written as y to the power n plus. So y is this one, no? Y to the power n plus 1. So there is one of this, don't know, you can, this notation, this we say chai. Okay. So we use this like a epsilon. We can have this one also a notation for the error. Okay. Y n plus 1 chai. Then pi x. I will explain what these things. Okay. Divided by n plus 1 factorial. So anyway, you don't need to use these things, but just to know. Okay. There is a proof. If you are interested, you can check how to get this formula. Okay. Okay. Here, y n plus 1. Give me a second. Y n plus 1 is the n plus 1 derivative. Okay. Of chai. This not in the upper. It should be here. Okay. We write like this, like this e, and we put like this. Okay. So y n plus 1 derivative of chai, and this is pi x divided by n plus 1 factorial. So you know n factorial, no? What is that n factorial means? Oh, at least n plus 1 factorial here. So n plus 1 derivative divided by n plus 1 factorial. So what is the n factorial? Can you give the answer? I write the formula for the n factorial. As well as n plus 1 factorial also. Okay. One person answered. Where's the others? Shall we call the name? 73. Can you answer me? What is n factorial? Okay, good. Yeah. No. That is not the answer, no? In factorial, it is the summation. Okay. So what is the answer? N factorial means n minus 1, n minus 2. You have to go up to 3 cross 2 cross 1. You have to go n to 1. Okay, you have to reduce. For example, let's say 4 factorial. What is that? Can you write the formula for the 4 factorial according to this one? No. 0, 0, 2, you have to go up to 1. Okay. So this is the formula for the n factorial. So okay, using this one, can you find the 4 factorial? Yes, which is equal to what? These are numbers now, you can multiply. So it will be, if it is n factorial, n minus 1, n minus 2, it goes up to 1. So if it is 4 minus 1, 3, 3 minus 1, sorry, 3 minus 4 minus 2. Okay, you can take like this. 4, 3, 2, 1. Up to, you have to go here. So these are numbers now you can multiply. 4, 3, 12, 24 like that. So like that you can find so many 8 factorials, what all these things. Okay. So tell me what will be the n plus 1 factorial from this to this. What will be that? Okay, good. Can you answer me for n plus 1 factorial? Only thing is you have to substitute wherever n plus 1, no? Okay. Okay, good. So it means if you are starting from n plus 1, then n plus, it's like 4 factorial. If I ask 5 factorial, what is happening? So n is 4. What is n plus 1? N plus 1 will be 5. The same thing happen now. 5 times, 4 times, 3 times, goes up to 1. Okay. So like that, n plus 1. The next number will be n, and then n minus 1. It goes up to 3, 2, 1. Isn't it? So we can take up to this point. What is that? Already there, no? We can take as the n factorial. So you can write n plus 1 time n factorial, or you can write fully. Okay. So for example, if they give like 5 factorial, 4, if you know already 4 factorial, what we have found 4 factorial now? 24. So 24. So 5 times 4 factorial. So it's like 5 times 24. It's like 120, isn't that? Is that correct? Okay. So this is what the factorial says. Okay. Okay, good. Thank you. So now let's see what this notation says. Okay. So you have to know these are for prime. Y is a function. Y prime we use for the one derivative. You know, you also use this notation also. You may see in the ODE sections. Okay. If it is double integral, we use 2. So if like n plus 1 derivative, we use this one. So the error is C. Okay. And here this pi x, see, you know this one, no? What is this notation used for? So I is equal to 1 up to n, something like that. What is this for? Yes. What is that notation for? It's a sum, isn't it? Summations. So if I say, let's say, for example, I is equal to 1 up to 3, okay, x. So what is the answer? Sorry, let's say xi, okay? So wherever I, you have to substitute with the consecutive numbers 1 to 3 and write with the plus, no? It's like x1 plus x2 plus x3. I can't go for x4 because I have stopped 3. So it has the plus signs. Likewise, this pi of x, maybe some people use I is equal to 1 up to n, like that. Okay, it means this one, multiplication. Okay, in here, okay, it's like this. Let's say this is xi, then xi times xi, sorry, x1 times x2 times x3 times, let's say this is 4 up to x4. It's like a multiplication. Okay, so this pi we use for multiplication, like summation for addition. Okay, in here they have explained pi of x is, you have to take this, if it is this x minus x naught, x minus x1 up to x minus xn. Okay, so it doesn't, we don't need this equation anyway, but you just understand this. Okay, so there may be, you can find some question in the charm series. They have used this one, they have proved this one, they have used this for some calculation. Okay, you can do that. We also are gonna use some examples. Okay, let's see. Okay, let me continue. So this is our error formula. Similarly, the collocation polynomial, this is one of the notes. Okay, the collocation polynomials can be expressed in terms of finite difference and factorial polynomial. Okay, when we are studying finite difference, we can study. Now just leave it. Okay, and then factorial polynomial also we're going to study next. Okay, so I'm going in order, so don't worry about these words. Okay, so it used this one. Okay, I will explain what is this formula, but we can see these things later. Okay, so this says yk is equal to, using the collocation formula, okay, polynomial, it is equal to y is equal to 0 to k. So what is this one? Have you seen this notation? Maybe stud people, or even in the school level you may see, no? What is this? What we call? This one? Maybe statistical people may see, no? Everyone studies some statistics. The school level, I hope somewhere you may see. Have you heard this one? Binomial coefficients. Have you heard? Ki. Anyone knows this formula? So you may see like this also, NPI, NCI, like that. Yeah, what is that? What is the name of that? What is the formula for that? We call this one as binomial coefficients. Anyone know the formula? Okay, combination. Yes. It's also combination. Okay, this is combination. Our lecture will be finished within 10 minutes. Okay, so right. So anyone know this formula? Hmm. Yeah, good. One person has answered. Yes, the others. Okay. So I don't want to take much time. So let's see. Yeah, good, good. Okay, you got it. So it is like Ki, it is like, there is some other formula also. So it's like K factorial divided by, you have to take this to this, K minus I time, K minus I factorial, then I factorial. Okay. So this is the formula for this one. Okay, that's that. And we use this, we can see in our continual courses, this delta we use for the difference. For example, let's say delta yk means you have to take yk plus 1 minus yk, like that. Okay, you have to take the earlier, the difference between the this and this. Okay, let's say this is my yk, this is my yk plus 1, and the interval between this one we use this notation delta yk. Okay, you can see later. So I power means, delta I power means maybe delta 1, delta 2, like that. Okay, okay, that's that. So we first list directly the Newton formula for the collocation polynomial, which the same equation. See, this is yk, this is pk. Okay, so same kind of equations. In some point, they both are coincide. That's called also collocation polynomial. Okay. So if you're interested, you just search around what it means, how you get this formula, that formula, everything there in that book if you search. Okay. Maybe it is also available in the online. You can download that book if it is possible, or you can get from the library or anything. Okay. So and then read through how all the if it is Charm series, they have it like a questions and everything, answers are there, so it will help you to study. Okay. Okay, that's all about the collocation polynomial. I will do some examples on it. Okay. Okay, let's do this example. Can you write down this example? And using our earlier you can find the solution. Okay, using our, what is our yk, what is the formula we have written now? Yk is equal to summation I is equal to 0 to k, again k I delta I y naught, isn't it? So using this, can you find what is they asking? So if it is y1 is equal to this one, y2 is equal to this one, you know this one, this formula. Okay, this one. So can you find out whether you can find y1 is what? Same this one, and y2 is this one. I'll give you 2 minutes. I'll come quickly. Can you do that? I need your answer. And after that, you can type and give to me. Okay? Send send in the our chat. Okay. Can I see first question's answer? Y1, at least. You have the formula. You know all these things in the formula. Just substitute. We have summation and this one. So each term you have to add. That's all the thing. Okay. I'll try first one anyway. You can do the second. Okay. So we know our functions yk is equal to summation I is equal to 0 to k. So if it is k, this n k. Okay, that's what you have to keep in your mind. Again, this k and this I. Okay, and delta of I of y of 0. Okay, so keep it in mind. This is our next step, which can be found from summation I is equal to 0 up to this number k, and then we find the permutation, that is k to this I, ki, and then we have the delta of this I and y naught. Y naught is what? Our initial y. Okay, initial, well, y naught. They didn't give y naught, so we can use y naught. Okay, so if you wanted to substitute k is equal to 1, you can get this one now. So k is equal to 1, so I is equal to 0 to 1. And then this one, 1i. Okay, delta, this will be I, and this will be y naught. So if you substitute this one, so what is 1i? One time now you have to, first of all, I is equal to 0. Okay, if it is I is equal to 0, this will be 0. This is what is the answer? 1 factorial divided by 1 minus 0 factorial will be 1 factorial, again 0 factorial. So what is the value of 0 factorial? 0 factorial will be, yes, 1. Okay, I think our meeting will be finished soon, so you can join again. This will be 1. So 1 time delta 0 y naught. Okay, is that correct? Yeah, plus what is the 1 1? If it is 1 1, what is the answer? 1 factorial